Hey everyone, we're Team 10 for iGen 230, and for our project, we chose to make an app called MusicMe, which aims to connect music to our emotions. Now, music is an amazing tool that allows us to enhance our emotions and introspect on past experiences through our connections to a particular song, or record, or album. But it can also provide comfort and strength and positive feelings that overall improve mental health. The problem comes when we have a particular feeling that we want to address with music, but we don't have the ability to identify that feeling, nor do we have the ability to pick out the perfect song. Looking at existing technologies for listening to music, there are obviously quite a few streaming services out there, like Spotify, like Apple Music. And while these have massive libraries of songs to choose from, it can actually be quite hard in the moment to identify what particular feeling I have. And it can be even harder to fully connect with a generalized playlist that's not truly for you. None of these have recommendations based on the unique user themselves, and none of these have mood playlists that actually detect the mood of the user directly.
The goals of this project are 1. Tailor music to fit a user's mood. 2. Remove the hassle of finding new music. And 3. Automate the song selection process. Decisions are difficult, and this means that you have one less decision to make in life. Some questions we considered to meet these goals are: how can we determine the user's mood? How can we connect mood to songs? And how can we tailor our solution to a wide range of audiences? After much discussion, our final solution for this project was to create a web-based application that uses Spotify to play individualized music based on a user's input to fit any setting or mood a user is in. And this solution is broken up into creating a user interface, developing app features, and working within a database.
When you first start in our app, you'll have to connect with your Spotify Premium account and validate through Spotify's authentication. Once you connect to Spotify, you'll see your name pop up, and you can start to select what type of genres you like to listen to. In this case, I'll pick pop and indie music. Now you're ready to start searching. I'm feeling great, so I can type it into the search bar and it'll give me some music. At this point, you can control by playing, skipping, and going back to songs you just heard. Users are able to like songs and see them on their like songs list. From the like songs list, users are able to see every single song they've liked in the past, as well as edit the list and play songs directly from the list. You can also dislike songs, and we'll learn from what you dislike and give you better recommendations in the future. Users are also able to discover countries. In this case, I feel like listening to music from France. Let's see what I get. I'm not a huge fan of French heavy metal, so I'm going to dislike this one. Let's see what I get. There we go, a song that I actually like. Finally, if you feel like just listening to any random old song, you can hit the feeling lucky button.
Here are the requirements that our team created at the beginning of the project. It was important to us that our app could detect emotion. Secondly, we wanted our app to work with Spotify to play songs. Third, and perhaps most important, was that our app could individualize music. The app should be able to match the user's mood 50% of the time. Finally, we wanted our app to be available on multiple platforms. Here's our technology stack. We chose to use Flutter and Dart as the main framework for this app because our original goal was to release this as a mobile app, available for both Android and iOS. We also chose to use this since the Flutter framework allows for easy integration of the front end and back end. VS Code is the main text editor that we use since it has extensions for Flutter and Dart, as well as working excellently with their respective plugins. We also discovered a really helpful extension in VS Code where we can all code together on the same file, kind of like how Google Docs works. Next, we use IBM's Tone Analyzer to determine the mood of the user's sentence. Each sentence or word will return one of 3 moods: joy, sadness, or anger, from which our app can decide what songs to output. Our database, which stores songs and user data, is hosted on a Firebase real-time NoSQL database, which will be detailed more later. The Spotify SDK and Web API is used to play the song, as well as getting play, pause, skip, and back features. And lastly, Python was used in the scripts to manipulate the database.
We chose to use a NoSQL database hosted by Google Firebase. Our database is categorized into 4 sections: user preferences, the log of user inputs, liked songs, and the song repository. User preferences contain the ranges of track attributes for sadness, joy, and anger. The log of user inputs is as simple as it sounds and stores the inputs from users. The list of liked songs is dynamic, like the user preferences section. Finally, the song repository holds all of the song data. More than 150,000 songs with attributes such as acousticness, key, tempo, energy, danceability, and more are stored. Just like the database, this app is dependent on 4 components: the Firebase NoSQL database, the IBM Tone Analyzer web API, the Spotify web API, and the web app itself. When a user inputs a string into the web app, we use an HTTP GET request to interact with the IBM Tone Analyzer to receive the tones contained in the string. We then categorize these tones into a mood. This mood is used to select the parameters for requesting what songs to take from the database. When we send a request for songs from the database, and then we store the unique Spotify track ID, song name, and artists for each track. To play a song, we then narrow down this list and send the unique Spotify track ID to the Spotify web API. The Spotify web API is also what's used to retrieve album art, to display the user's name, and also to retrieve the user's email.
Our app has many great features to help finding new music easier. Craving Colombian or Albanian music? Users can filter by countries. Only like specific genres of music? Users can filter by genre. Find a perfect song you just want to listen to over and over again? Users can add it to their list of liked songs. Don't like what song we give you? Users can dislike songs, and our app will learn what you like. Our app interacts with Spotify's web player. Buttons on our interface allow users to pause, play, skip, and go back to songs they just heard. We use a state management library called Flutter Block that communicates with Spotify's web API and returns data on whatever song is being played.
The genre selector was made by summarizing more than 5,000 microgenres that Spotify has created into 18 broader categories of genres. For example, one of the options the user can select is hip-hop/rap. When this genre is selected, a few of the microgenres represented in this category are Chicago rap, Birmingham hip-hop, Bay Area hip-hop, and Atlanta trap. The top process diagram shows how a song of specific genre gets played for the user. When a user selects a genre, it is added to a list of genres they want to hear. Because Firebase only allows you to query one genre at a time, a random genre from their list gets selected to query songs from the database. The country selection is implemented in the same fashion as genres. This feature works because some microgenres specify a country which the song or artist originates from. The Feeling Lucky feature bypasses the Tone Analyzer and only makes calls to the database and the Spotify web API. This feature gets a random song from our database using a random number generator by querying the index of the song from the database. A random song is then played for the user by sending the unique track ID to the Spotify web API.
Our like feature was developed to let users save their favorite songs and return to them later for further enjoyment. So if a user enjoys the recommendations they're receiving, they can press the like button on the user interface, and all of the song information gets stored in a list in a liked songs menu. So when they want to hear the song they liked again, all they have to do is click on the menu and then find the song name they're looking for that they've already heard, and it'll start to play again, even the next time they use the app. So this will allow for users to further explore new music and also to further resonate with the recommendations they're receiving when they work for them. On the other side, our dislike button corrects for errors in our recommendations when they aren't accurate. It's what truly allows for a unique user experience for everyone. So when a user dislikes a song by pressing the dislike button, a method in the app's backend updates the search ranges used for each song attribute, that being energy, danceability, and acousticness. It does this using a control algorithm that takes into account the actual energy, acousticness, danceability values of the specific disliked song and looks at where in the range that incorrect recommendation lied. And it only applies to the user's current mood. So we're basically telling the app, this song was a bad idea, it's a bad recommendation for when they're happy, but it's not necessarily a bad recommendation for when they're angry. And this will only apply for that user specifically. So this is what allows our app to have a unique recommendation for every unique user.
Testing was a key component in developing the backend of our application. When a new method or function was written, we would build a unit test to verify the inputs and outputs were consistent consistent with what we had expected to occur. Unit tests also allowed us to build functions and verify their efficacy without needing to connect anything to the UI. Once all unit tests passed as expected, we merged the recently finished functionality with the main branch of our GitHub repository. We then confirmed that all features remained intact after the merge. The final check was done after the UI was hooked up to the methods built in the backend. This process was repeated many times throughout the development of our app. Each feature, such as the creation of the list of liked songs and user authentication, had undergone this testing flow.
We had some of our classmates and other friends help to test our app. 21 participants within the ages of 18 to 24 were given a survey with a few multiple choice questions after they tried our app. The pie charts here show the results of this. The left shows the number of people who said the song matched their mood versus those who didn't, and the right shows the number of people who liked the songs played versus those who didn't. So, did we meet all of our requirements? First of all, our app can detect emotion. It can successfully take a sentence from the user and classify the emotion from the user's input using the IBM Tone Analyzer. As well, our app works with Spotify with the ability to play songs from Spotify, pause, skip, and go back to the previous song. Being able to curate music for our users individually was a key part of our app, and we were able to achieve this as well. Based on our testing, out of 21 people, 57.1% said that our app gave them a song that matched their mood. The users can also like songs. As well, users can select their music preferences, choosing both genre and country. Originally, our plan was to get our app to work on multiple platforms. Currently, we have our app available on the web and an app for iOS devices. Though our Android app is not completed, our app does work on Android devices through the web, so we count that as a win.
For the user interface, we wanted to create a calming environment and thus stayed minimalistic with a blue, white, and green theme and animated bubbles in the background. In the future, we hope to create additional features such as changing the color of the bubbles to fit the emotion of the user or allowing the user to pop the bubbles with a touchscreen. For future work, we hope to fix the bugs in the mobile app and get its performance working as effectively as the web application. We could also switch over to a professional machine learning system to have more accuracy between the mood and song selection. Finally, we are currently in the works of releasing an Android version to provide access to a wider audience. Be sure to check out our app, and we hope you enjoyed our project.